So now that we have definitions and the steps written out, let's go through this process of finding an x-intercept and a y-intercept. So I am going to write down the problem from the textbook, 5x minus 3y equals 15. And we're first going to find our x-intercept, or where we cross the x-axis. Step 1, remember, is to plug 0 in for y. So I'm going to do 5x minus 3 times 0 equals 15. So that's step 1 of plugging 0 in for y. This is what that looks like. Now, step 2 is to solve for x, and that's going to be this process we go through next. Well, I'm going to do 3 times 0, which really is just 0. So I end up with this 5x minus 0 equals 15. Subtracting 0 really doesn't do anything to my values. It doesn't matter what 5 times x is. If I subtract 0 from it, it's not going to do anything. So really, plugging 0 in for y, what that's done is it's just kind of canceled this out, really just leaving me with 5x equals 15. Now this process for solving for x means I need to get x by itself. And as we have learned earlier this year, we need to use the opposite operations being attached to our variable in order to solve for that variable. So what I mean by that is the 5 and the x are being multiplied together. I know it's not written, but when two things are written next to each other, that's implying multiplication as the operation, as the thing connecting them. So that 5 and x are being multiplied. The opposite of multiplication is division. So in order to eventually get down to x equals some number, and to get x by itself, I need to get rid of that 5. And the way I get rid of the 5 is using the opposite operation, which means I'm going to divide. Now, whatever you do to one side, you have to do to the other. And by sides, I'm referring to sides of the equal sign. So whatever operation or math I do on the left side of this equal sign, I have to do the same thing to the right side in order to keep that balance and keep it being equal. So dividing by 5, I end up with x equals 3. So this is telling me 5x minus 3y equals 15 crosses the x-axis at x equals 3. Okay. You could have also just said x-intercept is x equals 3. You could have said, written it as an ordered pair, which is more often what your textbook does, which would have been 3, 0. But it really doesn't make a difference. It all means the same thing. And so you can see here's their work of going through that process as well. Now we're going to find the y-intercept. So we are going to go through and do step 1, which is going to be plugging 0 in for x this time. So that plugging 0 in for x is that first step. Step 2 is solving for y. Well, 5 times 0 is just 0. Just like when we were finding the x-intercept, plugging 0 in for a variable cancels that whole piece out because 0 times anything is just 0. And adding and subtracting 0 really doesn't change anything for our numbers. So we really don't need to write this 0 minus 3y. We can just write this as negative 3y equals 15. Now we're also going to be using inverse operations. This negative 3 is being multiplied by the y, so I need to divide the left and right side of the equal sign by negative 3. And that gives me y equals negative 5, which means this equation, 5x minus 3y equals 15, crosses the y-axis at at y equals -5. Or in other words, our y-intercept is -5. And you can see the work in the textbook here. And then from there, you can plot those 2 points and connect them to get your graph. Because like we talked about in the prior concepts, you really only need 2 points to graph a line. And so finding x and y intercept can be one way to do that instead of creating the tables like we did in concepts 2 and 3. All right. Now let's go through example 1. So in example 1, we are given 10x plus 5y equals 60. And the goal in the end is to figure out what our x and y intercept is. The setup of example 1 is a story problem about Mary Ellen and scrapbooks or stickers. We need to figure out how many scrapbooks or how many packages of stickers she can buy with her $60 total. So this 60 is representing the total amount of money she has. It's $10 for each scrapbook, and it's $5 for each package of stickers. And so we want to know how many scrapbooks, or what does x need to be, when added with some number of sticker packages that give us a total of $60. Really what this problem is doing is wanting us to find x and y intercepts, but it's set up more as a story problem. So first thing is we are going to go through and find the x-intercept. And remember, x is representing number of scrapbooks. And y is representing number of sticker packages. So first, finding the x-intercept. And instead of writing out the full word intercept, I'll usually shorthand it to be INT, which is why you don't see me have the full word written here. I'll usually just shorthand it with INT instead of writing the word intercept. All right, so first thing we want to do is plug 0 in for y. Simplifying this down, we would get 10x plus 0 equals 60. Adding 0 really doesn't do anything, so we really have 10x equals 60. Solving for x, we divide by 10 because that's the inverse or opposite of multiplication. And we get x is equal to 6. What this means is with $60 in hand, Mary Ellen can buy at most 6 scrapbooks. If she buys no sticker packages, she can buy a total of 6 scrapbooks. Now we're going to go through and find the y-intercept to say, well, if she buys no scrapbooks, what's the most number of sticker packages she could buy with her $60? And so to answer that question, we will find the y-intercept. Here, to find y-intercept, you're plugging 0 in for x. Ten times 0 is really just 0. So we end up with 0 plus 5y equals 60. Adding the 0 really doesn't do a whole lot, so we really have 5y equals 60. Now, solving for y, we divide by 5 because that's the inverse of multiplication. And we end up with y equal to 12. So in the context of the story problem, we could say Mary Ellen can either buy 6 scrapbooks with her $60 or she can buy 12 packages of stickers with her $60.